Hello guys, welcome to this video of image processing application. The purpose of this video is to show the project 2, which is image processing application, is working and running properly on Android device. So these are the functionalities I have implemented in this project. The remaining functionalities are implemented as a part of the phase 1. So in this project 2, our task is to implement the last two options, that is AG and baselines. So let's start with AG. So the operations we need to perform to get this AG is to first we need to convert the image to grayscale using OpenCV methods. Then we need to take Laplacian of image, and then third one is the threshold that age image into binary age image. And at the last we need to cycle through the image row by row, and each pixel set the final image which equal to the bitwise and between the original color and the red image. So let's see this functionality of AG. So yeah, after clicking on AG, we can see this functionality as it only shows red pixels when the pixel value is 255. So let's move to the next functionality, that is baselines. So the procedure behind achieving this baseline is to first we need to convert the original image to the gray. Then we need to take Laplacian of the image by applying the matrix Laplacian filter. So then we need to perform some operations on these half lines. After that we need to choose lines which has angle between 0 to 30 around the vertical, and then we'll get some red lines. So let's start with the baselines. So this is the original image, and after clicking on this baseline, so here we can see some blue lines and red lines. So it displays the red lines only when the angle between the line around the vertical axis is between 0 to 30. So that's it. So we can see both of these features is working properly and it's running on the real device, that is Android device. Thank you. So this is the code of this application, and now we are in Android Studio. So this code is developed using Java programming language. So let's start with the AG functionality. So here we have used this imageproc.cvt color to convert the original image into grayscale image. Then we have created array which name is time, and this array is of size gray dot rows into gray dot columns, which is the size of grayscale image. Then here we have created 2D matrix 2D array, which is matrix of filter, which is nothing but the Laplacian filter, which we'll use to multiply with the original image. So this Laplacian filter has 3 by 3 array size, and this is the final result 2D matrix to store the final results. So let's talk about this nested while loop. So this nested while loop is for to cycle over all the rows to get the current pixel using gray dot get. Basically, we are cycling over each and every pixel of grayscale image. Then we are multiplying this grayscale image with the Laplacian filter, and we are storing the result in this final result matrix. So here we have access uh, the different I and j values, and we are multiplying it with Laplacian filter, and we are storing it in final result array. Then this code is to convert this 2D matrix final result into the 1D array, that is the simple array. Here we are using this clone function to copy the image mat into this temp where. So this while loop is basically to render over each and every element and check if it is greater than 50, then assign it to 255 pixel value, which is white color. I'll assign it the 0 value. And here we have created the red line matrix, which has the values that is 255, 0, 0, which indicates RGB, and here the value of R is 255. So again, I have used this nested while loop to cycle, like to retrieve each and every pixel going through rows and columns. And here we are basically we are getting each and every pixel of this red matrix, which represents red image, and then we are accessing the pixel from this temp array. Then here we are multiplying a red image matrix into the original image, and then we are storing the result. And finally, we are returning this updated temp var. So this is all about the AG. Now let's start. Now let's start with the baseline. So here you can notice that the first starting part for the baseline is similar as that of AG. Like we are converting these original image into grayscale image. Then we are taking these filters, that is Laplacian filter, and this code is the same as in AG. Like we are multiplying uh, the pixels in our original image with the Laplacian filter. So up to this much the code is quite same, but here we are using this image.canning for the edge detection. Then here we are calculating the width and height using this function image.mat into height, and this is the constraint on this. Like it is mentioned by our professor that if do like this, if width image is less than height image, then the final is just 1/4. So these are basically the thresholds. Then we have created these two arrays of size 10, which we'll use for the top 10 lines. So finally, this while loop is for to calculating uh, the slope and to get the angles. So we have used this slope Yeah, so we have calculated the slope, and then we are just calculating the cos theta, sin theta, and here, like it, after calculating the angle uh, by using this tan function, we are calculating the angle from from the slopes, and then again we are checking this condition like the angle is less than 30, and then we are taking this count of the top 10 lines, and here we are creating these lines which has the red color. The scalar 2550, shows that these lines we are creating has the red colors, and we will create number of lines which is equal to this final count variable. And finally we have written these image mat which consist of the output of the baselines. So both of these functionalities, AG and baselines, is working properly, and it's also running successfully on the real Android device. Thank you.